A penstock pipe is a crucial component of a hydropower plant, serving as a large, high-pressure conduit that transports water from the reservoir or dam to the turbine. Its primary function is to channel the gravitational energy of falling water into kinetic energy, which drives the turbines to generate electricity. Key features and functions. 1. Design and material. Penstock pipes are typically constructed from robust materials like steel or reinforced concrete to withstand the high pressures and forces exerted by the flowing water. Their design is engineered to minimize friction losses and maximize efficiency. 2. Pressure management. As water flows through the penstock, it can create significant pressure changes. Engineers carefully calculate the diameter and slope of the pipe to ensure optimal flow rates while managing pressure levels, preventing potential failures. 3. Flow control. The penstock may include valves and gates that allow operators to control the flow of water, enabling adjustments based on power demand and system conditions. Impact on efficiency. The design and condition of the penstock directly influence the overall efficiency of the hydropower plant. Smooth, well-maintained pipes reduce turbulence and energy losses, contributing to higher electricity generation. Safety considerations. Regular inspections and maintenance are essential to ensure the integrity of the penstock, as any leaks or damage can lead to significant operational issues and safety hazards. Overall, the penstock pipe is a vital element in the hydroelectric generation process, playing a key role in the conversion of water's potential energy into usable electrical energy. Its design and maintenance are essential for the safe and efficient operation of hydropower plants.